Alright, number 5 is asking us this question: which equation models the parabola that passes through all of these points? They gave us an intercept here, which could be helpful if we knew the right equation template. And another strategy here would be to take these coordinate points and to substitute them into these equations. So on part A, I could just say that y equals x squared plus x plus 4. So 9 plus 3 is 12. 12 plus 4 is 16. 16 does not equal 0. So A is not true. Now I'm going to take this coordinate point again, and I'm going to use it in part B this time. So I have, when y is 0, I have negative 3 squared plus 2 times 3, and then plus 3. 6 plus 3 is 9, and 3 squared is 9. When it's negative, it's minus 9. So negative 9 and positive 9 equals 0. So this coordinate point for B works out. I can put 2 and 3 in here. When y is 3, x will need to be 2. 2 times 2 is 4. 4 minus 4 is 0. 0 plus 3 is 3. 3 equals 3. So 2, 3 works out for us. Now let's test our last coordinate point. When y is 4, x should be 1. 2 plus 3 is 5. 5 minus 1 is 4, and 4 equals 4. So all of these coordinate points will work out for me, which means B is my final answer. Okay. So the next one they ask us here: which quadratic function is shown by the table below? A couple of different ways you could do this to get you started. So let's take a look. Okay, so for number 6, it asked me which quadratic function is represented in the data table below. This is a non-calculator question, so I'm going to do it graphically first. One of the easiest ways to do this is just to go through and plot all the coordinate points, just real quick as a sketch. Nothing major, nothing big. When you do that, you can see that you have this coordinate point right here, which is 0, negative 36, and you also have this coordinate point right here, which is 1, negative 36. This means that your vertex will have to be, because of symmetry, will have to be halfway between the two. So about 1/2. That's still not helpful because all of these will have an x vertex of 1/2. So not super, super helpful. But if you think about it, your y-intercept happens here at 0, negative 36. So what that means is when x is 0, y has to equal negative 36. So I look through my equations. If I put in a 0 here, this will go away to 0. If I put in a 0 here, this will go to 0. And I'm left with y equals negative 36. This seems to work for us. Let's try the other ones. If I multiply a 0 here, that goes away to 0. That goes away to 0, and have negative 16. When x is 0, y equals negative 16. That's not what that says, so it's not G. You can already see it right here. This will be 0, 0, and then negative 24. Y equals negative 24. Also not true. If I put a 0 here, 0 times 0 will all be 0. This whole thing will go away to 0. And the coordinate point is not 0, 0. So F has to be the right answer. All right, number 7, which equation best describes the relationships between the variables x and y with these coordinate points? Well, let's take a look at some of our equations that they give us here. Is it a linear function? Is it an exponential function? Is this a quadratic or a quadratic? The only way to really be able to figure this out, I think, without a calculator, the fastest way would probably be to look at a graph real quick. Let's take a closer look on a separate sheet of paper. Okay, so we've got a coordinate point 212, and we're going to see if it works in A. A was y equals 3 times x. So the coordinate point 212 will say 12 equals 3 times x. Does 12 equal 6? No, it doesn't, so that means A can't be the right answer. Let's look at B. B says y equals 3 to the x, and we are looking again at the coordinate point 2, 12. When y is 12, x is 2, and 3 squared is just 3 multiplied like this. 3 times 3 is 9. 12 does not equal 9. So B is not true either. Part C says x squared divided by 3. So y equals x squared divided by 3. And our coordinate point again was 212. So we have 12 equals 2 squared divided by 3. 2 squared is just 4. 4 divided by 3 is not 12. And part D, y equals 3x squared. Again, when y is 12, x will be 2. And 4 times 3 is 12. 12 equals 12. So this must be my final answer. Number 8, the table shows the average braking distance of a car at various speeds. And use a quadratic model to predict the braking distance at 70 miles per hour. So for us here, this means that if we need to use a quadratic model, that would be something like y equals x squared. We should probably take a look at what this means with a real equation. So let's develop our equation given this data, and then we'll figure out what the braking distance is for 70 miles an hour. So in this one, they give you the data table, and you want to put this directly into your calculator. So I can go to the home screen. I want to get to a new document and go ahead and clear out everything that was there. And we can add in our list and spreadsheet. I'm going to put x at the top, y in the next column, and I'm going to go ahead and type in my data table. Okay, now that I've got all of my data in, it's time for me to go ahead and run my regression to see what the equation would be so that I can actually predict out the braking distance. So I go to Menu, Statistics, Stat Calculations, and they tell you specifically use a quadratic model. So I'm going to go to Option 6, Quadratic Regression. I can change this to x and this to y, and I'm ready to go ahead and have the calculator tell me the equation. Here's my equation right here, ax squared plus bx plus c, and then they're going to tell you what a, b, and c are for you to be able to put those in. Okay, so now that we have our equation, they asked us a very specific question, and it has nothing to do with writing down the equation. We don't need to actually write that down. We just need to predict the braking distance at 70. So to have the calculator tell you what it is at 70, I'm going to hit Document, and I want to go down to Insert, a calculator. And we named this graph, this regression graph, F1. And they're asking me for what F1 is at 70, when x is 70. And F1 at 70 is 245. So that means that my answer option needs to have 245 in it. That's going to be answer G. 245 feet. They give us another question on number 9, and this one was very much similar to number 5 and number 7. They're going to give you a couple of coordinate points and just ask you which one could model for you. Again, I'm going to take the whole numbers again just because it'll be a little bit easier for me to apply. And if y is 16, then x is 2. 4 times 2 is 8, and 8 is not 16. On part B, again, y is 16, and 4 squared. 16 does equal 16, so this seems to work out for us. X squared is 2 squared. 2 squared is 4. 4 divided by 4 is 1. 1 does not equal 16. And again, 16 equals 4 times 2 squared. So 2 squared is 4, and then 4 times 4 is 16. Again, these are not the same thing. So if I put in maybe an 8 in here for x, 4 times 8 squared. 8 squared is 64, and 64 times 4 is 256, and they want it to equal 1.5, not 256. So I know that D is not my answer either. This means that I'm ready to go. B is my